So today we are going to talk about similar figures. But first, before we start talking about similar figures in practice, we have to define the parts that go with similarity. So in order to be similar, a polygon has to have the same shape, but a different size. So these triangles here are obviously both triangles, but they are different sizes. They are similar polygons, but they are not congruent. Remember, we've talked about congruent a lot in the past, and that means it is the same. Similar figures are similar. They are not the same. However, there is one aspect of them that is the same. In a similar figure, corresponding angles are always congruent. The angles are congruent, but everything else about the shape is proportional. So corresponding sides are proportional. I'm not on the screen. Here we go. So they are proportional. This ratio of the corresponding sides is what is known as the scale factor. If polygons are similar, then that means that their perimeters are also similar. If you think about it, perimeter comes straight from the side of a shape, and if the sides are proportional, then their perimeters have to be proportional also. Scale factors are the ratios of corresponding sides, and the order of the sides matters. So in the example we're about to do, it gives you the order of the letters. It tells you that it's A, B, C, and then D, E, F. But if it didn't tell you that, and you just had to look at it, you would look at the angle markings. This has one circle, or one arc, so you're going to match it to the same in the other triangle. So A and D would be the same, and B and E would be the same. When I'm making the scale factor, you're just making a ratio. Remember, a ratio is just two numbers. In this case, it is one side from each of the triangles that is corresponding or in the same position. If I just pick AB, that started at one semicircle and went to two, I'm also going to have to use DE because that starts at one semicircle and goes to two. If I make my scale factor here, it would be 8 over 12. One side over the corresponding side. Remember, they are proportional, so you can do it like this. This is not a simplified ratio, so that means I've got to simplify it. I'm going to put it in my calculator, and it is going to give me a ratio of 2 to 3. So my scale factor for triangle ABC to triangle DEF is 2 to 3. Now if I were to flip that, what is the scale factor of DEF to ABC? I'm going to use the same two sides, just because why not? But I'm going to start with the one that goes for DEF. That would be 12. So it would be 12 to 8. That is not in the simplest form, so I'm going to simplify it. And that would give me a ratio of 3 to 2. Now I've got to find the perimeter because I want the ratio of the perimeter of my bigger triangle, DEF, to my smaller triangle. Perimeter, remember, is adding all three sides. So to find the perimeter of ABC, I'm going to add 8 plus 10 plus 18. That would give me 36. So my perimeter for triangle, I should say, ABC is 36. Then I'm going to have to do the same thing to find the perimeter of DEF. So I have 12 plus 15 plus 27. 12 plus 15 plus 27 is 54. So now my ratio of the perimeter of DEF to ABC would be 54 to 36. That is not in simplest form. But remember up here I said polygons are similar, then their perimeter is also similar. Is also proportional, kind of like their sides. When you put this in, it is the same ratio as the scale factor that we did above. It is also 3 to 2. And that is because those sides are directly proportional, as well as the perimeters. Next, we've got to talk about similarity statements. Similarity statements are similar to when we wrote congruent statements. It was where one triangle is congruent to the other, and you base the corresponding angles and sides together. It's the same thing. We just have to learn what the symbol for similar is. It is this little squiggly guy. And for the triangles above, it's kind of already given it to us. But if we were to match the angles, this has 1, 2, 3 semicircles. 1, 2, 3 semicircles. So it would be triangle ABC, similar to triangle DEF. Remember, if you don't have corresponding angles and sides, then that means you cannot have a similarity statement because the triangles would not be similar. Looking at the practice problems, there we go. We've done something similar like this when we did congruent angles, or congruent triangles, I mean. So the first half of this is going to seem very familiar. When we did congruent triangles, we matched the order of the letters in our similarity statement, or then it was our congruent statement. I'm going to say the J comes first in my first triangle, and the P comes first in my second triangle. So angle J has to be congruent to angle P. Now if I go to the second letter, I do the same thing. K, M, angle K is congruent to angle M. And last but not least, the last letter. That would be angle L is congruent to angle N. Now if I do sides, I do the same thing, but they are not congruent, remember, when they are similar figures. They are proportional, so I am going to write a proportion. If I start with the first set of sides, that would be JK, because remember a side is 2 letters. And then PM would be the first 2 letters in the second, so there is my first proportion. If I go to the next one, that would be KL and MN. And then last, LJ and NP. Number 2 is very similar, so pause the video if you'd like and see if you can figure it out. If I match the order of the letters, here are the angles that are congruent to each other, X and R, Y and Y, because they're the same, and Z and S. Now if I were to do my proportions for my sides, it would look something like this. Pause the video, see if you can figure it out. See if you got it right. Remember, the order of the letters does matter here. Okay, so going to number 3. Now we have these 2 figures. We'll call this figure A and figure B. So from figure A to figure B, my scale factor is 2 to 3. So if I were to make a proportion for that, it would look like this. Now if I'm looking at the sides, because I have to figure out X, I'm starting with A, which we said was this one. Let me label it. So that would make this 42. And the one that goes with B would be X. Now, I've got a good proportion that I can cross multiply. So I'm going to do that. I'm going to cross multiply. That gives me 2 times X and 3 times 42. So in order to find X, I'm going to divide both sides by 2. When I do that, that gives me X is equal to 63. Just a 2-step proportion. Multiply and then solve for X. Okay, looking at number 3. I've got something similar, but instead of it giving me the scale factor this time, it gives me a triangle and wants me to find the missing side. So in order to do that, I'm going to use the similarity statement, and I am going to match my sides together. AB is my first side. That's 25. And in my second triangle, DE is my first side. That's X. I've also got to do something so I can figure it out. You're going to make a proportion, and in doing that, I'm going to have to identify the second side. It's a little bit easier now that you've done the first. So BC is proportional to EF. So now this is what my proportion looks like before I solve it. Looking at it, I'm going to cross multiply like I always do. So it's going to give me 700 is equal to 20x. Now it's okay if you get these bigger numbers as long as you divide. Remember, these are proportional sides, so the sides are going to kind of be in the same range number-wise. To find x, I'm going to divide by my coefficient. So x should be 35. Okay, and then my last problem, number 5, is very similar to how number 4 was. The only difference is it's got 2 expressions for each side on the second triangle. But that's okay because we know how to set this up now. I'm going to look at my similarity statement and I'm going to say AG is my first side. And AG matches KX. So I can set up my proportion, 32 over x plus 3. And then I'm going to do the same thing for my second side. GM is proportionate to XD. That would give me 36 over x plus 6. I'm going to cross multiply. Now remember, because these have expressions, I'm going to make sure I multiply both things on the inside, so I'm going to write it out so that I can distribute it easier. After I do that, that gives me 32 times x, which is 32x, and then 32 times 6, which is 192. So on my other side, I'm going to multiply the 36 through, so that gives me 36x plus 108. Now to get x by itself, I'm going to move the smaller coefficient, which would be 32. So I'm going to subtract the 32x. Then to get x by itself, I'm going to subtract the 108. That should give me 84 is equal to 4x. To get x by itself, I'm going to divide by the coefficient. So x should equal 21. If you have questions, remember, reach out to your teacher. Good luck.